Welcome to
Yep.
your first online virtual classroom.
Yay.
So very good afternoon to you. I hope you already have your lunch. So
Yes.
let's do it. No lunch?
We forgot Joshua.
Got Joshua. It's okay.
Maybe he doesn't know how go use Zoom.
Yeah, anybody know what happened to Joshua?
I don't know.
I can
Okay,
text him
okay, never
if
mind.
you need. Okay.
You can try to ask him to try. But if he really cannot, then it's okay. This session is recorded, hopefully. And I will send it to the group after this. Because I tried to record today's morning session with year 9 class, but I don't know why it is not recorded. But it's okay. We'll just try it again. Now 803. Yes,
Are they also recording what we are saying?
of course.
What?
The whole session is recorded, not just my voice. The whole session, including your voice. Yeah.
Wait, can you hear me?
Yes, I can hear you
Okay.
clearly. It's a bit soft on Hebe side though, but it's okay. I can still hear.
My phone.
No, it's okay. So, have any of you read through 803 notes?
Yes.
Anson, have you started doing your 803?
I finished physics notes.
Physics, but not chemistry.
Not yet.
Okay. I think later on when I completed this class, right, this lecture, right, this session,
Yeah.
I'm also able to send all these notes to you. We can try. Then you all can do notes from there lah. This is yeah. If you want the notes, I can send it to you. Let's just go through the lesson first. So chemistry 803, what is it about? It is everything you need to know about hydrogen. Okay, so in this 803 we are studying hydrogen alone, hydrogen element.
Yes.
Now before we start our class, I would like to go through a few vocabulary. The first one is displacement reaction. Displacement reaction is the reaction in which hydrogen gets displaced from its compound like water, acids, and alkalis by more reactive metals. Alright, if you are a bit confused, it's okay. We will go into details later on. The second one is activity series of metals. Activity series of metals is a list of metals arranged in order of their decreasing reactivity. The third one is redox reaction. Comes from the word reduction, oxidation, reaction. Okay.
Yep.
Redox. Okay. Redox. Redox reaction in which oxidation and reduction both occur simultaneously. You also learn it, maybe not in this lesson, but a future lesson on what is oxidation and what is reduction. So don't worry. All you need to remember is these two words, oxidation and reduction. Now the final one is catalytic hydrogenation of oils. Catalytic hydrogenation of oils is a process in which liquid with vegetable oils are treated with hydrogen under pressure in the presence of nickel, palladium, or platinum to make solid ghee. So these three things is not added into ghee, but it acts as a catalyst. Maybe you do not know what is catalyst. Okay, this is
Yep.
extra. Catalyst is an agent that speed up a reaction. Okay.
Yes.
Just bear that in mind. So we have done with vocabulary. Now we come to this boring history of hydrogen.
Yay.
I myself personally don't like history, but it's okay. Now, the first one who got a clue about hydrogen is this Robert Boyle. He did an experiment in 1671. That was like almost 400 years ago. And when he mixed iron with acids, he noticed that a bubble is produced. Okay. And today we know that the bubble produced is actually hydrogen gas. But at that time maybe he still do not know yet. So, but this is his observation. He mixed iron with acid. Iron is ferrum. It's a element. It's a transition metal or transition element. Okay. So all you need to know is iron is a type of metal. So it mix metal with acids, and bubble is produced. Now later on, about 90 years later, 95 years later, Henry Cavendish, he did the same experiment and he collected the bubbles. So he want to investigate what is the bubble. The collected air, okay, which is the bubble. Okay, the collected air is flammable. So he tried to ignite the air and he discovered that the air is flammable. So he called it flammable air or phlogiston. Very glamour name. He also tried to study the properties of hydrogen, and he did a very significant discovery. He discovered that when you burn hydrogen, okay, it produces water. Okay, so
Yep.
hydrogen, oxygen, burn,
Water.
burn, you get water. Okay, we discovered that. Now, after about 10 over years, this guy called Antoine Lavoisier, I don't know how to pronounce. Perhaps that's how he pronounced. So he actually gave the names hydrogen to this hydrogen element or atom. He named it based on a Greek word. Hydro means water. Gen come from the root word of generate. Gen, it brings a meaning of forming. So hydrogen, the meaning is water forming. I think he got the idea from these studies. So Henry Cavendish found out that hydrogen produces water when it is burned. So Antoine later named it as hydrogen. Now, hydrogen is the most abundant element on Earth. It is essential to all life form. So if you don't have hydrogen, you don't have life. I mean, because
Mm.
all the essential component of life, for example, carbohydrates, your DNA, your everything, amino acids, everything contains hydrogen. So it is the essential element to all life form. It is also a source of fuel on Earth. Okay, fuel is used to provide energy, whether for biological processes or for engine operation, industrial operation. It provides energy. So anything that is called fuel provides energy. So hydrogen actually provides energy, is a form of a fuel on Earth. It is the lightest element. It is non-metals, although it is grouped in, if you still remember the periodic table, group number 1 is alkaline metals. Okay, group number 1 is called alkaline metals. But although hydrogen is grouped in group 1, it is not a metal. It is considered a non-metal. Okay, so hydrogen being the lightest element, of course, it is lighter than air. So how do we prove that? How do we prove that hydrogen is lighter than air? All you need is a Wolfe bottle, tester funnel, delivery tubes, what is that? Trowel and rubber stopper. Okay, this is the Wolfe's
Yes.
bottle, tester funnel, delivery tube. Okay, what else? Rubber stopper, rubber stopper, rubber stopper. Yep, that's about it. So tester funnel, I think the function of tester funnel is to insert things into this bottle, and then this bottle is where the reaction happens. Rubber stopper is to stop air from coming in or going out. So the air actually can only goes into the bottle or comes out from the bottle through this delivery tube. Okay, other than that, all the space is sealed by this rubber stopper. Delivery tube, of course, is to allow air to pass through. So I'll explain how this experiment makes sense. So first we need to arrange the apparatus as shown in the figure. So we take zinc and put it into the bottle through this tester funnel. And then we pour some diluted sulfuric acid into the bottle. And immediately you will observe that small little gas bubbles will produce. So where did these bubbles go? The bubbles, the gas from the bubbles will pass through the delivery tube and enter into the second bottle. Okay. Of course, if in order to enter these second bottles, you need to pass through this caustic soda solution. The function of this caustic soda solution is to remove all the acids that follows the air. It kinds of like a filter where it filters out acid. So the air coming out is free from acid, and then it will enter into this bucket, or just call it bucket, and then this bucket contains this soap solution. Why it is it use soap solution? So that the bubble will form easily and will not pop. So the air produced here will pass through this so-called filter, and then pass through this soap solution and trap inside the air bubbles. The observation that is made here is that they notice that the bubbles it floats and start floating upward. Okay, start floating upwards. Of course, maybe it's not a straight line. Maybe it's this way, but it floats upwards, which means because lighter air travel outward, but while heavier air will travel downward, right? So the fact that we can observe the bubbles floating outward indicates that the gas produced, which is the hydrogen gas, is lighter than atmospheric gas. So far, any question?
No.
Oh, Joshua joined. Hi, Joshua.
Yay.
All right. So the observation here is bubbles floats. Now, hydrogen combines with other elements to form compounds. For example, hydrogen combined with oxygen form water. Water is very abundant in our Earth, planet Earth. You can find water in ocean, in seas and rivers, lake, ponds, water vapor in air, underground water, pipe water, tap water, drinking water. Okay, so if you combine hydrogen with carbon, you form hydrocarbon. Example of hydrocarbon is natural gas, petroleum, oil, and etc. Hydrogen also combine with carbon, oxygen, and nitrogen to form organic compound. For example, carbohydrates, which we call a sugar, fats, proteins. All this you will learn in your 903. Okay, and even DNA contain carbon, oxygen, and nitrogen. So it occurs in you can find it in almost all living organisms. And when hydrogen combine with chlorine, sulfur, nitrogen, and oxygen, it forms acids and alkalis. Okay, it is prepared in laboratory. Now, move on to the last session of 1.1, which is isotopes of hydrogen. So hydrogen have 3 isotopes: protium, deuterium, And oh, the third one, I didn't type. Hold on. The third one is tritium. Okay, tritium. Protium is the most abundant non-radioactive isotopes. It has 1 proton and 0 neutron. Okay, it has an atomic mass of 1. Proton number 1. Nucleon number 1. Electron 1. Deuterium, okay, deuter means 2 or second. Indicates that it has atomic number of 2. Okay, now when we say isotopes, do you still remember what is isotopes? Anyone?
Isotopes?
Yes, what is isotopes? Do you still remember?
Wait, what's it called again?
The elements that have the same number of what?
Protons,
Protons and electrons, and different number of
neutrons.
neutron and nucleon, right? So for isotopes of hydrogen, protium, deuterium, and tritium. They always have a proton number of 1. Okay, because it belongs to group 1. So group 1 have a valence electron of 1. Since it is the lightest element, you have 1 proton. The difference between protium, deuterium, and tritium in terms of their atomic structure is that protium do not have neutron, so it is the most common hydrogen that we see or we know every day. So neutron, let's put N. Neutron is 0. Deuterium, okay, deuter is meaning second or 2. It means that the nuclear number is 2. So if nuclear number is 2 and proton number is 1, what is the number of neutron? Anyone? So the number of neutron, yes, someone just unmute. Yeah, answer? Joshua, you want to answer? Okay, never mind. Deuterium, since nuclear number is 2 and proton number is 1, therefore the number of neutron is, oh wait, someone just type it in. Okay, your mic not working. All right, noted. You unmute already. Yeah, we saw that. It's okay. You can, yeah, you can actually, you can just communicate with everyone using the chat. So let's come back to this deuterium. Deuterium, proton number 1, nuclear number 2, which means its number of neutron is 1. Tritium, tri, okay? You don't even have to guess. You have already known that the nuclear number is 3. Therefore, since its nuclear number is 3 and proton number is 1, its number of neutron is 2. Okay. So we have protium here, deuterium here, tritium. Let's look at deuterium.
Understood.
Yeah, I heard some sound. Wait,
Yep, I fixed my mic.
oh,
Yay.
good. All right, get back to the lesson. Deuterium, mostly prepared by electrolysis of heavy water. It is non-radioactive. While tritium, it is a radioactive element or atoms. It is formed in upper atmosphere by reaction induced by cosmic rays. So we have to thank God that it is not happening or formed in the atmosphere, at the lower atmosphere. If not, we will be exposed to this radioactive. So this tritium, maybe scientists have a way to produce it inside a laboratory as well. So scientists use it, or people generally use it as a radioactive tracer to trace maybe the area that is affected by radioactive, in case there's a damage or failure in a nuclear plant. So it is used as a radioactive tracer to trace the effect of or the area affected by the radioactive substance. And it is chosen because it is cheap and easy to handle. All right, so we have done 1.1. Any question before we move on to 1.2?
Nope.
No.
No, great. Now let's move on to 1.2. 1.2 is preparation or production of hydrogen. We are going to study how hydrogen is produced. There are three different preparation. Okay, we have displacement reaction. Why is it not? We have a displacement. Let's just zoom in. Displacement reaction. Okay. For Joshua, because you have missed the first 5 minutes of my lesson. So
Yep.
here is the definition of displacement reaction. Displacement reaction is reaction in which hydrogen gets displaced from its compounds like water, acids, and alkalis by more reactive metals. All right, if you don't get it, it's okay. Just keep this in mind. Reaction in which hydrogen get displaced from its compound. Okay, so you expect a displacement is happening. So here is the same. It is obtained by its displacement from compounds like water, dilute acids, or alkali by more reactive metals. So in order for this displacement reaction to happen, the compound that contain hydrogen have to be mixed with a more reactive compound. For example, potassium, sodium, calcium, magnesium. Okay. So here we have a list from the most reactive elements to the least reactive elements. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold, platinum. So from this list, we know that potassium is the most reactive element, followed by sodium, followed by calcium, then magnesium, then aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold, platinum. So based on this statement, displacement reaction is obtained by its states that the hydrogen is obtained by its displacement from compounds like water, dilute acids, or alkali by more reactive metals. So theoretically, the position of hydrogen in this reactivity ranking is over here. So theoretically, everything that has all these elements supposed to react and release hydrogen. Okay, so that's why it is very common for laboratory for lab to collect this hydrogen from using this method. So how do we actually obtain or prepare hydrogen? Yeah, several methods using displacement reaction. First of all, it is a reaction of water or steam. Steam means water in gaseous form. Okay, when you boil the water, you get steam. So it's the same. H2O in liquid form, H2O in gas form. So when you mix water or steam with metals, look at the example here. We use potassium. Remember, potassium is belongs to group 1 and it is a alkali metal. So when you use potassium and you mix potassium with water, you will get hold on. I think this formula is wrong. Yep, it's wrong. So when you mix potassium, which is a kind of metals, with water, you will get potassium hydroxide and hydrogen gas. Okay, this is the formula. But this method is highly exothermic. It means this reaction release a lot of heat, and the metals reacts with water violently. If you still can recall your 802, you have studied about the reaction of potassium, sodium, and other group 1 elements with water, namely what else? Lithium, right? So when it reacts with water, it produces a hiss sound, correct? And acidic solution, colorless solution. Okay, please study back your 802. So it produces hydrogen gas and acid. Now this is not recommended in a laboratory or lab because it is highly exothermic. It reacts violently, and also sometimes if you're not careful, it explodes. Okay, so it is very dangerous.
Will
Oh.
we die from the explosion?
Depends on the amount of chemical produced will determine the magnitude or how serious is the explosion. If it is serious enough, yeah, it will put your life into danger. But normally, if you are producing in lab, it is small amount. So yeah, it probably won't hurt you, but you still have to be very careful.
Okay.
So reaction of dilute acids on metals. Now displacement reaction, the hydrogen is displayed from compounds that contain hydrogen, such as water, acid, alkalis, right? So in the second reaction, we will be looking at the reaction of dilute acids on metals. The example given here is magnesium and zinc. Both react with what kind of acid? This is sulfuric acid, H2SO4, sulfuric acid. When magnesium or zinc react with sulfuric acid, you will get magnesium or zinc sulfide. Okay, magnesium sulfide, zinc sulfide, and hydrogen gas. For this reaction, there are many things that you have to take note. So in this particular reaction, if you are using, if the metals you are using is a potassium, sodium, or calcium, it is explosive and dangerous. But if you use lead, okay, lead I think is Pb. If you use lead with acids, the reaction will stop after a while. Why? Because when the reaction happens, it produces insoluble salt. Okay, this is salt, this is salt. So when you use lead, it will also produce salt, which is insoluble. So when the insoluble salt coated the outer layer of this metal, it will prevent the contact between these metals and also acid. Hence, the reaction will stop. Now, dilute nitric acid is not used because nitric acid is a very strong oxidizing agent. Sorry for so many typo. Due to it being a very strong, strong, strong oxidizing agent. TT, what is TT? It will release nitric oxide or nitrogen dioxide, which is not what we want. We want hydrogen gas, not nitric oxide or nitrogen dioxide. That's why dilute nitric acid is not used. Now, all these methods is only produces small amount in lab, and it is not used in a commercial scale because it is not cost effective. It means if you want to make it as a mass produce it, this is not the methods that you go after. Now, when metal mix with when reactive metal mix with water, you produce hydrogen gas. When reactive metals mix with acids, you produce hydrogen gas. Now, when reactive metals mix with alkaline, we will also get hydrogen gas. We just look at these two examples here given. To zinc, zinc plus KOH, KOH is potassium hydroxide. Potassium hydroxide. We produce potassium zinc oxide or something like that, and hydrogen. Okay, if aluminium with sodium hydroxide and water, we produce this salt and hydrogen gas. So I'd like to take a pause. Any question here?
No.
No?
No.
Okay,
No.
so we'll move on. Now, the commercial preparation. This is how hydrogen is mass produced and sold by these chemical companies. The first methods that that can be used in the commercial scale is and normally used in commercial scale is electrolysis of water. Electro means electric. Lysis means breakdown or separate. So electrolysis of water is a separation of atoms in the water using electric, okay, or electricity. Now, it is done by passing current through water, but there's one problem here. Water is a pretty bad conductor. That means if you are in pure, ultra pure water, you probably won't get a chance to be electrocuted if high voltage is passed through the water, because ultra pure water, it is very bad conductor, and it will not conduct electricity. But raining water is different. Raining water is slightly acidic, so it improves the conductivity of the water. So we do not advise you to play outside if there's a thunderstorm. Now back to the topic. Water is bad conductor, so in order to speed up the reaction, normally a few drops of sulfuric acid are added just to acidify the water. So at this point, probably the water will be like the acidity of this water will be like acidity of the water of rainwater we have. So when the water is acidified, now when you pass through current, electrolysis happen. Okay, the separation of atom through electricity happens. So one of the example is shown in this picture, electrolysis of water, where you have cathode, which is negatively charged, and anode, positively charged, and this is probably water. Both of this is water. What happened is when the current is passed through, at anode side, oxygen gas is released. While for cathode side, hydrogen gas is released. So if you, let's say, put a tube here and collect it into a tank, you'll be able to collect pure hydrogen gas. So the advantage of this method, hydrolysis of water, is that you can obtain a pure hydrogen gas. But there's a disadvantage. Disadvantage is that this method is very costly. Why is it so? Because it involves electric current, which means you need to pass through electricity, and electricity is not free. It is very expensive. Now the second method is Bosch process. It's a very simple method, mix and collect. So they use Coke. It's not our Coca-Cola. This Coke is CO. Okay, CO, carbon monoxide, and water. So when you mix carbon monoxide and water, you will get carbon dioxide and hydrogen gas. Now it's very hard to separate hydrogen gas with carbon dioxide if you're using this method, but it is very cheap, and you'll be able to obtain hydrogen without costing you a lot. Now the third method for commercial preparation is steam reforming, where you mix methane gas with water. Okay, methane, the chemical formula for methane is CH4. Okay, and when you mix with water, it will produce carbon monoxide and hydrogen gas. Now, I think both of these it's very hard for you to get pure hydrogen. Only through these methods that it is possible to get a pure hydrogen gas, electrolysis of water. Other than that, you always get a mixture. It's either carbon dioxide and hydrogen, or carbon monoxide and hydrogen. Now, before I move on to the laboratory preparation, any question here? Oh no.
No.
No? Okay, move on to our last part. I think we are able to end before 3:30. Now the last part is laboratory preparation or lab preparation. So let's go straight into the photo. Okay. The apparatus needed is let me enlarge this. It's a flat bottom flask. So this is a flat bottom flask. You need a 2-hole rubber stopper. This is a 2-hole rubber stopper. 2 holes rubber stopper. And we have a delivery tube. Okay. When dealing with gas, it's always delivery tube. Delivery tube. And you have a gas jar. I think this is the gas jar. Okay. And you have a beehive shaft. This one. And a straw. How do I actually pronounce? How is this actually pronounced? Well, for chemical, you need zinc and acids. So it is actually very similar to, you know, the one we learned in our 1.1. Okay. But it is a simplified version of it. So you skip this. Okay. You skip this. Because you don't need to know whether, you know, it floats in the air or not. So you don't have to use that soap water. Okay, it's almost the same. So step by step, first of all, zinc granules is placed inside the flat bottom flask, and you close the flask with the rubber stopper. Tester funnel is passed through one hole, and delivery tester funnel is passed through one hole, delivery tube is passed through another hole. So you need to set this up before you start the reaction. So when things are set up, then only you open this. This is kind of like a tape. Okay, when you open, only the hydrochloric acid will start flows into the flat bottom flask. So you prepare your acids here, your zinc here, and put on the rubber stopper with tester funnel installed and also the delivery tube installed. And then delivery tube will lead to this beehive shaft. Probably there's a hole here. Okay. And then a gas jar is placed on top of beehive shaft. And you have water here to prevent air from coming in. Okay. So the gas jar is inverted over the beehive shaft. I think the gas jar must first fill with maybe the same thing lah, water. Full. You need to be full, so that when gas started to come in, all you have is hydrogen gas instead of mixture of hydrogen gas with atmospheric gas. So now once you have set up the apparatus, you turn on the tape. Okay, turn it on, and acid will start dropping into on this zinc. So wait until the acid is the zinc is completely submerged in the acidic solution, and you will notice a vigorous reaction will take place, and you'll start witnessing small bubbles containing hydrogen gas coming up. So the gas will not pass through here, will not pass through here, will not pass through here. It will go into the, what tube is this? Delivery tube, right? Yeah, delivery tube. And then the delivery tube will lead the gas into gas jar. So when gas travel inside gas jar, because gas jar has a fixed volume and gas takes volume, so when gas comes into this hydrogen this gas jar, water is forced out of the gas jar. Okay, water is forced out of the gas jar, and the water is displaced by hydrogen gas over here. So in this method, hydrogen displaces water. Yeah, so that's how you actually produce or prepare hydrogen gas in a lab when you need only a small amount of hydrogen gas. Now there are a few safety precautions that you have to observe and practice. First of all, the apparatus must be airtight so that the gas will not leak. Okay, in case gas leak and it is very concentrated, any spark will result in explosion. but normally it will not happen. Secondly, no flame should be brought near the apparatus because the mixture of hydrogen is highly flammable. If you want to cause explosion, of course you can bring the flame near hydrogen gas. But if you want to be safe and you want others to be safe and you do not want to destroy the lab or the apparatus, you need to keep it away from flame. Now, the lower end of the thruster funnel should be completely covered with dilute acid. And the first few bubbles of hydrogen gas should not be collected because they contain air. So instead of hydrogen gas, so you need to first allow a few seconds of and the first batch of air to release into atmosphere before you start to collect the air, so that
Wait,
you get
so
the
don't-
pure hydrogen. Yes.
So they said don't collect the first few bubbles because they contain air,
Yeah.
but then
Initial-
bubbles are from air.
Initially, when you set up this, right? So here here contains like atmospheric air, and inside your delivery tube also. So when the reaction starts and bubble coming out, it pushes this air out. Okay, so all this atmospheric air will be forced out. So if you start if you collect the air immediately, this kind of air is collected, which you do not want because it's not hydrogen gas. So instead of collecting the air immediately, you need to let maybe you don't connect it to this gas jar first. Okay, you let the air escape. So until when the air is completely displaced by hydrogen gas, then now you start connecting this and collecting the air produced in a gas jar. That's what it means.
Okay.
Clear?
Clear.
Yeah.